Okay. Good afternoon, everyone. My name is Mohammed Koroma. You are welcome to our YouTube channel, Professional Academy. Today we have a question here, WAEC pass question. Let me look for the year. WAEC pass question 2002. The question reads: the diagram is a portion of a right circular solid cylinder of a radius 7 centimeter and a height 15 centimeter. The center of the base of the cylinder is Q, while that of the top is B, where angle ABC and angle PQR is equals to 120 degree. Calculate correct to one decimal place A, the volume, and B, the total surface area of the solid. And if you can see here, if you can see the solid, 120 of the solid is being removed, 120%. So before we solve this, the first thing we need to do is to take out our data. Yes. So if you read the question again, the diagram is a portion of a right circular solid cylinder of a radius. So the radius is given to be 7 centimeter and the height h is given to be 15 centimeter. Okay. And angle, okay, AB, ABC is 120 degree, and which is equals to angle PQR. So we are asked to calculate the volume, but pi is given to be 22/7. Alright, before I solve this question, I just want to explain something. If you have a circle like this, let's say we have a circle like this. If we are asked to find the area of this circle, we just go straight, which is pi r square. But let's say this circle was divided into 4 sections, and these 4 sections are all equal, and you are asked to find the total surface area. So in order to find, okay, let's say one of the portion was removed, and only this is remain. So in order to find the total surface area that is left here, it's just going to be, since we have 4 portion, so that will be 4 all divided 4 down. And how many sections do we have? If you see here, we have 3 sections left, which will be 3 times it by the total area, which is 3/4 times pi r square. That's how we can find the area of this. What if this area here was the one we are asked to find, this area here? So that's just going to give us 1/total, which is 4, times pi r square. So that was just going to give us the area. So with this idea, we can use it to solve for this one. So if you remember again from the previous class, we said volume of a cylinder is equals to pi r square h. But if you check here, let's check here again. 120 is out. 120 is out. So if you try to trace it, you will see that here, out of 360 degree, if you remove 120, you are left with 240. So inside will be 240. So from here, it's going to be 240. Let me wipe it and let me redraw it here. So you have a circle like this. 120 is out. So we are left with 240. So in order to calculate the volume that is left, it's going to be the 240, not the 120, because 120 is out of the diagram. So to find the volume now of this diagram, its volume is equals to 240, that is left out, divided by the total, which is 360 degree, times it by the volume of a cylinder. So we have our values. We can just go straight and rectangle A, sorry, B, okay, A, B, E, Q plus rectangle D, C, Q, R. Look here, this alone is a rectangle and it's part of the areas. This alone is another rectangle, and then we have the curved area here, and then we have the up and down. So we have to cater for all of them. But if you look here, the height here is given to be 15 centimeter. So here also is going to be 15. The radius is 7, 7, so 7, 7. But so let's find the area of the two rectangles. So the area of these two rectangles now, since the area of the rectangle is length times breadth, but here we are just given the radius and the height. So we can just say it's the radius times the height. But since two of them, we are going to multiply by 2, because this and this, they are going to have the same surface area. So that will give us 2 times the radius times the height. So let's find this answer. 2 times the radius is 7 times by 15. That will give us, I think it's 210. But let me check it. 2 times 7 times 15. Yeah, that will be 210 centimeter square. So we are done with the two rectangles. Now we are going for the circle, the two circles up and down. The circular areas. So if you look at the circular area, like I said here, the diagram is here. 120 is out, so we only have 240. But we know the area of the circle is 5 arc square. And if 240 is left, so meaning we are just going to find the area of the bigger sector. So it's not a full circle anymore, so it's a sector. So to find the area of a sector, we can just use theta over 360 times by the total surface area of a circle. And here our theta is 240 because it's the one that is left and not the 120. So that will give us 240 divided by 360 times 5 arc squared. But if you remember, there are two sectors we have. We have one sector up and another sector down. So we can just multiply by 2 to make it 1. So that will give us 240, but we know 240 is 2 over 3, so we can just simplify that times the pi is given to me 22 over 7 multiplied by the radius is 7, which is 7 times 7 is the same as 7 squared. 7 multiplied by 7 times the 2. This 2 is because there are two sectors and both of them are equal. So this 7 will cancel this 7 out. So that will give us, let me clear here. So it will give us now 2 over 3 times 22 times 7 times 2. This 7 is out. So let me multiply down and see. Up and down. We have 2 multiplied by 22 times 7 times 2. Let me go again. 2 times 22 times 7 times 2. Okay, divided by 3. Okay, if we divide by 3, that will give us everything up is 616 divided by 3. If we do that, it gives us 205.33. So this is the total area for the sectors, which are the circle up and down. So let me think to put here a second. Okay, so that will give us a final answer of 2 1 205.33 centimeter squared. So this is the area of the sector. So instead of circle, it's sector because it's no more a circle, it's now a sector. Okay, let me clean up here to find the curved area because we have a rectangle, a sector, two sector, and a curved area. So if you look at the curved surface area of a cylinder, the curved surface area of a cylinder is equals to 2 pi RH. So this is the formula for the curved surface area of a cylinder. But if you remember again, like I said, have some parts of this cylinder has been removed. So it's not going to be the total. This is not the one we are asked to find because 120 of it has been removed. So in order to find it, since we know the angle, we just do the same thing, which is 240 divided by 360 times by the formula, which is the 2 pi RH. But we also know this, which is just 2 divided by 3 times 2. Pi is 22 over 7 times the radius is 7 times by 50. So if we multiply this together, that will give us, okay, let's cancel out this, cancel this, 3 into itself 1, then into this, that will just give us 5. So that will give us 2 times 2 times 22 times by the 5. So 2 times 2 times 22 times by 5. So that gives us a total of 440 centimeter squared. But since the question asks us for the total surface area, the total curved surface area, so we are just going to add it for the total surface curved surface area, which is going to give us the curved surface area plus the sector area plus the rectangle, the two rectangles we got. Okay. So if we do that, that will give us the curved surface area we got 440 plus this sector area we got 205.33 plus the rectangle we got 210. So if we sum this together, that will give us 240 plus 205.33 plus 210. So that gives us 855.3. But if you remember from the instruction, it says calculate correct to 1 decimal place. That will give us, okay, let me just remove this. So that will give us 855.3 centimeter squared. So this is the total surface curved surface area of this solid. But let's say if the question asks you to find the area that was removed, how do you think we are going to find that? If you can see in this, since when the area we found is we have two rectangles, the one you also cut out, there will be two rectangles. So let me just give you the formula you are going to use, and then you can send your answer in the comment section. So to find the area out, the area that was cut out. So the area out is going to be, don't forget, we are going to have still two rectangles there. So the two rectangles you have there, which is same, plus, now the curved surface area there, but there instead of putting 240, we are going to put the opposite angle, which is 120. So we can just put 120 over 360 times the curved surface area, plus, now the sectors, instead of using 240, you will be using 120 over 360 times the sector area. So this will be the formula you are to use if you are asked for the area that was removed. Thank you for watching. Try to help us to share, subscribe, and comment.